Hello students, I am Dr.Gajendra Purohit. You are watching my YouTube channel where I upload videos on engineering mathematics B.Sc. If you are preparing for any competitive exam where higher mathematics is asked, then our channel is very helpful. Students, I have started uploading videos on discrete mathematics where I have already uploaded many videos. You can find the link in the description or on iTab or in the pinned comment. In this video, I will tell you about finite state machine. Equivalent concept will also be explained. When we have two finite state machines, so when are they equivalent? Like we have finite state machine here, also finite state machine. Students, as you can see, here are S0, S1, S2, S7 state, and here is S4 state. We have reduced three states from here. So I reduced it, and here we have finite state machine 2 and finite state machine 1, both are equivalent. So what will be the process that we will follow by which this finite state machine gets converted into this one? And we will also learn how to delete the states and how to minimize them. Okay, now let's move ahead. So what is the equivalent finite state machine? Two state machines are said to be equivalent if starting from their respective initial state, they will produce the same output sequence when they are given the same input. Okay? If we are getting same output on giving same input, then this type of machine is what? It is equivalent. But listen, when we calculate the equivalent state machine, then we remove some states and keep some states. Now there is a process of removing these states or minimizing them. It's not that it is done randomly. There is a process of doing this, right? I will tell you what is that process. Lot of questions are asked in exam on this. How to minimize the finite state machine and get the equivalent finite state machine? I am going to tell you that, okay? So let's see how we will do it. Now the very first thing that you have to understand is that how to calculate the zero equivalent state. Here we will get one equivalent and then two equivalent, and we keep calculating till k equivalent. So what is that process? First of all, let's understand its definition. First of all, what is zero equivalent state? So two states are said to be zero equivalent if they have same output. If we have any state whose output is the same, then we have that state as a zero equivalent state. Is this clear? For example, as you can see that we have this here, right? Yes, this is just for example. So we are seeing that the output of this and this two states is here. It means here we have 1, 2, 3 and 4 states, and the output of these states is 0, right? Here we have these two states and their output is what? It is 1. Output of these two is same. Therefore, this is also zero equivalent. If output of this and this is 0, then this is also zero equivalent. But we will have a separate set for this and a separate set for this, right? Both the states are known as what? Zero equivalent state. Don't get confused that only that state will be zero equivalent whose output is 0. It's not that. If any state gives the same output, then it comes in one category, and that is also zero equivalent state. If we get output 1, it will also be zero equivalent. But this will belong to different category. Keep this in mind. So let's understand this concept using this table. You can see in this table which state is zero equivalent in this table. Here is 0, S1, S2 and S3. This is zero equivalent. Similarly, this state here is also zero equivalent. But this and this are different sets. So we need to keep this in mind. Okay. This is what I wanted to explain to you guys. We will understand this in more detail ahead. Now let's talk about what is one equivalent state. Two states are said to be one equivalent if they have the same output and if every input, their successors are zero equivalent. Okay. It means input of their successor should be what? It should be zero equivalent. Now students, I want to give details to you. Let's consider we have these two, S0 and S1. We need to determine if these states are one equivalent or not. Okay. We already know they are zero equivalent because their outputs are the same. Now let's see whether these are one equivalent or not. Let's see their successors. We will take S1 and S5. So here this is S1, right? Here is S5. Are the outputs for these two the same? You can see output of this is 0. Here output of this is also 0. It means these have same outputs. So this is zero equivalent. Next, let's consider S2 and S3. Here this is input. You can see this is S2 and S3, right? Here output of these two is also 0. Sorry, same. It should not be 0, but same. Okay. If this is 0, then this should be 0. Otherwise, if this is 0 and this is 1, it's wrong. Both should be same. So here both will be one equivalent. But you guys might be feeling that this process is very complicated and tricky, right? Students, we can understand this in a shorter way also. Now I am going to tell you that trick that how we will find if this is 1 equivalent or not, or if it is 2 equivalent or not. So we will understand all these. For instance, if you are asked whether this is 2 equivalent, so same, now what we will do here, the input successor of two states that we have in this case should be what? It should be 1 equivalent, right? So to check 2 equivalent, you check for 1 equivalent in their input successors. Similarly, if you want to determine if two states are 3 equivalent or not, then in that case you would check if their input successors are 2 equivalent or not. They should be 2 equivalent. You can see this process is quite complex. For this we have certain concepts, certain tricks that can help us quickly check whether it is 1 equivalent, 2 equivalent or not. Students, I will also explain that, how to minimize finite state machine. Now let's move ahead. So like this we can understand K equivalent. So if we have to check for K equivalent state, then input of successor of whatever two states that we have should be what? It should be K minus 1 equivalent. Is this clear or not? For example, to check 2 equivalent, we check for 1 equivalent in their input successors. So I want to illustrate this concept, that how to easily find it. Here let's consider this table as an example. Using this table, I'll demonstrate how we can determine 0 equivalent, 1 equivalent, 2 equivalent, and even 3 equivalent. And finally, I'll show you how we can use these concepts to minimize this, right? We will be covering this. By minimizing, we can derive its equivalent finite state machine. So I'll tell you this. First of all, we will see which are 0 equivalent states, okay? So you need to pay attention that whenever we determine 0 equivalent states, see here, the output is either 0 or 1, okay? The states whose output is 0 will belong to the same. And this will be 0 equivalent, okay? So S0, S1, S3, S4, this is 0 equivalent. And for which the output is 1. This will also be 0 equivalent, but this will belong to a different set. For example, S5, S6, and S7. So we can write like this. If we are talking about the 0 equivalent, we can denote it by pi 0. Here we will write it like this, S0, S1, S2, S3, and S4, right? Can you see this or not? And in a separate set, we will have states S5, S6, and S7. Okay, we will write it separately. Okay, very good. Now let's move ahead. You must have understood till here. Now, let's see if these are 1 equivalent or not. Let's examine whether these are 1 equivalent or not. Let me erase this part so that you can see properly. To check for 1 equivalent, we need to find value of pi 1. Now, we have to identify which states are 1 equivalent, right? So what we will do next? Whenever we have to check 1 equivalent, then in that case, first of all, we will take S0. Yes, you heard it right, S0. So students, S0 gives this output here, S1 and S5. Okay. See, where is S1? It is here. We will name this 1 and this is 2. Keep this in mind. See, this is S1 and this is S5. See here, S1 and S5. This is coming here and this here. So this will be pair 1, 2. We will name this as 1, 2. Clear? Now, let's talk about S1. Right? If we look at S1, what is coming for it? S0 and S5. Here this is S0 and here is S5. This will also be 1, 2. Clear? Now let's consider S2. It has S6 and S0. S6 is here and S0 is there, making the pair 2, 1. How it became 2, 1? Because first S6 is there, then S0. You need to pay attention to this. Now we will take S3 here. So what is coming for S3? S7 and S1. So we have S7 here and S1 is here, this resulting in 2 1s. Do you understand? Now let's see S4, whatever is coming here we will see. So S4 is here and it has S0 and S6. This S0 is here and S6 is here, forming 1, 2. So this will be 1, 2. This will be there. S4 will be 1, 2. Now we will see which are giving same output. Like here, this is 1, 2, this is 1, 2, this is 1, 2. This is 1, 2, this 1, 2, this 1, 2. We will write them together. Now we will have S0, S1, S4. These will be 1 equivalent state. So I am right or not? The remaining states are also 1 equivalent, but their output are different. So they will belong to a separate class. You need to understand this concept properly. Now we will talk about this one, how to do this one. So let's erase this now so that we don't face any problem in understanding the next part. Now students, let's talk about this one, S6, S7. So S6, S7 and next we will take S5, right? Let's take these. Now we took S5 and in S5, S7 and S2 is coming, right? So this is S7 and S2 will be here. Therefore it will be 2, 1. Okay. Then we will talk about S6. So S6 has S0 and S3. Here is S0 and same here is S3. Therefore it will be 1, 1. Now we'll talk about S7. In S7, we have S0 and S2. So S0 and S2 is here. This will also become 1, 1. Pay attention to this. Now take those which are giving same output in one class. So students, here we will have S5. And here we will have S6 and S7. Is this clear? Pay attention to this. There is one more thing you need to understand. Here is S5, S6, S7. I broke and brought it here. Now you will have a question in your mind that, sir, this is one equivalent, but are these two states one equivalent? So this is one equivalent. But these two states are not one equivalent because they belong to different class. Their output is different. So guys, whenever we see this, the successor of input should give same output. Okay. Is this clear? Output of S6, S1 is 1, 1 and output of S5 is 2, 1. Getting my point? This is what we have to understand from this table. So this will be different and this will be different. Although it is 1, 1 equivalent, but their class is different. Now let's talk about S0, S1 and S4. Now we will determine 2 equivalent, right? What we will determine? 2 equivalent, write it as it is for 2 equivalent. If this is 1 equivalent, then it will also be 2 equivalent because we have the same outputs, so it does not have any problem. Now we will break this one, okay? So let's understand that. How to break this one? Now we will talk about this state, okay? So we will write S0, S1 and S4. Now when we take it out, then we will name its class separately. We will give it 1, here will be 2, we will give it 3, here will be 4. There are 4 classes, we will give different names. Now let's see S0, we have S1 and S5 in S0. S1 is here and S5 is here, so it will be 1, 3, right? So keep this in mind. Now let's talk about S1. We have S0 and S5 in S1, okay? This is S0 and this is S5. This will also be 1, 3. Now let's talk about S4. Here, this is S4. In S4, we will have S0 and S6. If we have S0 and S6, then it will be 1, 4. So these two will be in same class and this one will be different. It means that both of these, like S0 and S1 that we have, these two are 2 equivalent and this is also 2 equivalent, right? Is this clear or not? But these two are not equivalent to each other. You need to understand this. Now everything is equal. So whenever we have a minimum of 2 classes or 1 class, then where does it belong? It comes in the same class and then it gives the same output. There is no need to go in further details. Now let's minimize it. So we need to understand how to minimize. Please listen to me very carefully. Because we will minimize it here, right? Remember now that whenever we have S0 and S1 here, it means these 2 classes are what? They are the same, okay? Because we have the same output of this here, right? So you can remove one thing from S0 or S1. So what I do is, like here we had S0 and S1, I will remove one of them. Because we are minimizing it, so now if you feel like removing the S0, you can remove it. If you want to remove the S0, you can remove it. But I will remove the S1. You can remove any of these. Remove one from the same class that we have. Okay, now S4 here is alone. So it will be like it was before. Now here is S2 and S3. So remove one from S2 and S3. We need only one. What we will do is, we will remove this one and keep this. Let's move forward. Here's the S5, so it will be left alone. Here's the S6 and S7. Remove one from S6 and S7, so I will remove the one below. Remember that whatever you removed, it should not be visible in the table. It should not be seen in the table. Now moving forward, let's make a table here. So let me make this table properly. This will be the state and this will be the input. And here this will be the output. This is the output. We need to pay attention here. Now we have 0 and 1 in the input. Clear? Okay, now please see here that what we have here. One is S0, one is S2, next is S4, next is S5, and after that S6. Right? Can you see this or not? Here we have S5 and here we have S6. Is this clear? Now let's talk about S0 that is here. You can see that we have removed the S1, right? If we remove S1, then it will not be in table, okay? You can see S0, S2, S4, S5, S6. Here in input and output, there will be same things. Especially the state that I have removed in the input, it should not be there. Like S1. S1 should not be here, right? But S1 is equivalent to what? S0, so S1 and S0 are same, right? So here we can write S0. Now see S5. It is S5, so here this will come. This is what you need to pay attention to. Now let's see S2. Now this is S6, S0. Is S6 coming here? It's coming, take it. Now what's next? S6 and S0. It is okay. Now you can see here we have S0. Now let's talk about S4. Here we have S0 and S6. S0 and S6 is here. Okay. Here will be S0 and S6, right? Now what is output of this? Its output is 0. Now let's come to S6. Sorry, let's come to S5. It is coming to be S7 and S2, but we don't have S7 here. Instead of S7, we can write S6 because it is of the same class. Is this clear? So we will write S6 here. And S2, we have S2 here, so it's fine. No problem. And what is the output we have? Listen, it's 1, right? Like this, if we talk about S6, we have S0 in S6, but not S3. So what can we write instead of S3? We can write S2, okay? This will come here and this will come here. What do we get of this? Minimize table and these two state machine are equivalent to each other. If you want to take S1 instead of S0, you can do that. If you want to take S2 in place of S3, you can take that also. So all I want to say is yes, you can take that. It will be a different state finite machine. Okay. So there is no problem. And this is the method that I have explained to you, right? This is the table and here we have its equivalent state machine. I have told you there, so you can see. Let's move ahead. So let's see this question. What will we do here? First of all, we have to check if the output here is 1, 1. So we will take this together and the 0 state that we have, in that we will get S0, S2 and S4. And after that, we will take those. Output of which is coming to be 0. So it will be S1 and S3. So this will be 0 equivalent state, right? This is 0 equivalent and this is also 0 equivalent. They will be 0 equivalent to each other, but they cannot be for each other. Now let's talk about pi 1. For pi 1, we know that we will write this as 1 and this as 2. Clear? Now we will talk about. Next, we will take S0, S2 and S4. Now when we take S0, it will be what? S3 and S1, okay? Is this clear to all of you or not? So here S3 and S1 are coming. This will be 2, 2, right? This needs to be taken care of. Now let's talk about S2. So here S2 is coming to be S3 and S0. This is S3 and this is S0. Therefore S2 will be 2, 1. Now let's talk about S4. Here see S1 and S0 is coming in S4. This is S1 and this is S0. Therefore S4 will also be 2, 1. Now you can see that this is the same output and this is different. So if we break this, then we will get this and then we will get this. S2, S4. And listen, we only have 1 here, so there's no need to worry about it. Now as soon as we get it 2 or less than 2, then we do not need to check it further. It will come in the same category. Also, when you take the pi 2 of this, then pi 2 will be this only and pi 3 will be this. You can check it. So we got this here. Now what we have to do? We have to calculate its finite state machine and then we have to minimize this. When we calculate equivalent finite state machine and minimize this, same remove those of same class. Like here S0 is single one here, so we need those which are single, right? Now here is S2 and S4. We can remove one from S2 and S4, so I will remove S4 and I will keep S2. Clear? Here is S1 and S3. Again, we can remove anyone from these. Here I will remove S3 and take this. Now write this table again. So we will write table here. Tell me what will we get here when we write table. Here state. So students, here this will be the input. Here this will be the I1 and I2. And here this will be what? Output. Is this clear or not? Okay. Right. So we will get this. Now let's write in this. We will write whatever we actually need. So we want S0, S1 and S2. Right. After S0, S1 and S2. In input S3, S1 is coming. And we don't even have an S3. So which class do we have for S3? S1. So instead of S3, we'll write S1. See here, this is also S1. So this will be 1. Now here it is S4 and here S1. But we don't have S4. So S4 is coming in which class? S2. Therefore, we will take S2. Here will be S1. This will be 1. Now S3, S0. There is no S3. In which class S3 is in? In S1. So this will be S1 and this will be S0. And here this will be 1, right? So this will be what? Its equivalent finite state machine. And like this, we minimize this. Okay. I think now you would be getting this thing. Like this we do it. Now let's see the next question. Question is saying for the finite state machine shown below, list all 0 equivalent states. Second part is find all equivalent states and obtain an equivalent finite state machine with the smallest number of states. Same, we have to minimize it. Now we will talk about the states which are 0 equivalent. So same, we will take pi 0. Okay. Now look here. Which are the states whose output is coming to us as 0? So this is, and here this is. It means A, B, C, D. Okay. Here A, B, C and D will come. And those whose output are 1, actually here it will be A, B, C and E. It will be E, right? What we will get here? E, is this clear or not? Here other one will be D, F, G, H. Yes, it will be D, F, G, H. So this is what we will have. Zero equivalent state, right? Now students, we have to calculate its one equivalent. Therefore, we will write A, B. Here A, B, C and E. Now let's see A. We have F and B. So F is coming here and B is coming here. So it will be 2, 1. Now let's talk about B. So DC. D is here, C is here. So this will also be 2, 1. If we talk about C, then G, B, G is coming, B is coming here, then it will be 2, 1. Now let's talk about E. Here we will have D and A. Here D and A, so this will also be 2, 1. So guys, we have all 4 states same here, okay? There's no need to worry. We have all of them as what? It will be one equivalent, right? Let's talk about it now. No need to worry. If it is not coming, we will move forward. We will check in the next state where it might break. Now let's talk about D, F, G, H, right? Since it is D, F, G, H, if we talk about D, so E, A is coming for D. Is this clear to all of you or not? So E, A is coming. Here we have E and A, therefore this will be 1, 1. Now let's talk about F. We have A, G coming for F. Here is A and here is G. It means it will be 1, 2. Okay. We will talk about G. We have C and H and G. Here is the G and here is the H. Now what will be this? Here this will be 1, 2. Let's talk about H. It will be A, H. A is coming here. H is coming here. It will be 1, 2. So this A will be separate and these 3 will be separate. Now what we will do is this will come here, this will come here, and then we will get F, G, H. Okay. F, G, H. This will be the one equivalent state. Again, we will give names like 1, 2 and 3. Clear? This is what we will do. We have to do this work next. Like we calculated one equivalent, same we will get 2 equivalent. We have same here A, B, C and E. So here we will write A, B, C and E. Okay. Now tell me, is this clear to all of you or not? Let's talk about A. Here what we will get? We will get FB. Here we have F and B. So it becomes 3, 1. Now let's talk about B. So we have D and C coming in B. D is here and C is here. Therefore, it becomes 2, 1. Right. Next, we will talk about C. C is coming to be G and B. Since G is here and B is here, so it will be 3, 1. Right. Let's talk about E. In E, D and A is coming. Here is D, here is A, so it will be 2, 1. Now this is broken. Both of them will be in the same class, so it will be AC here. So when we calculate pi 2, then we will get AC here and we will get B here. You can see that it has been broke. Here D will come alone. Okay. Now we will take F, G, H. What will be value of F, G, H? We are going to do same work with this. I think now you have started to understand things. It's a little lengthy, but it will be done. Okay. Now let's talk about F, G and H, right? First, let's take F. We have A, G in F. So A is here and G is here. So it becomes 1, 3, right? Now let's talk about G. We have C and H coming in G. C is coming here and H is coming here. So it will be 1, 3. Now we will talk about H. Here you can see A and H is coming in H. This is also 1, 3. Here as we can see all 3 are coming to be 1, 3. It will break in the next one. F, G, H. This will come. Now we will talk about pi 3, right? So for pi 3, this will come. 1, 2, 3, 4. We will take this, right? There is no need to write this. It will come as it is because this is done. We can't go below this. This is also done. This is also done. Now we will take this FGH again. Yes, you heard it right. We will take FGH again. But before that, I will remove this one so that screen is clear. Okay. Now listen, we have F. So here you can see AG, right? So A and G is here. It is 1, 4. Is this clear? Then we will take G. We have C and H for G. So this is C here and this will be H. So it will become 1, 4. Now let's take H. So AH. So A is coming here again. H is going to be 1, 4. This is a problem. So as you can see, the output that is coming here is the same again. Here each output is same. This simply means that. Now we can't break it furthermore. Okay. It means these 3 states are equivalent to each other. So there is no need to worry. Do you know what we will do next? Now we will minimize it. Let's see how to minimize it. First of all, we'll talk about A and C. If we remove one from A and C, I'll remove C. Let's keep A. Now let's talk about B and E. From B and E, I will remove E. Okay. Now since D is alone, we will keep it. We can remove any 2 from FGH because we need only 1. So what we will do, we will keep F and remove G and H. When 3 states are there, then one of the 3 has to be kept and 2 have to be removed. If 4, then keep 1, remove 3. But we have to try till it is minimized. Okay. Is this clear? By chance, if the output is not the same, and by breaking when we reach till last, like nothing is happening, and we are getting 1, 2, and 3. So, then only we have to do something like this. It's not like that we have to same here. No. Till the time we don't get the same output, we will do this work. Okay. So, let's remove G and H. So, here G is removed. Okay. This will be removed. And we will get this, we will be left with 4 states. So, let me write it again. Let's change it just a little bit. Okay. This will be the state and here this will be the input. So, this will come to us as 0 and 1. And here this will come to us as output. Is this clear? Now, what do we need here? We need A here, B here, D here, and here F. Okay. You need to pay attention to this now. Listen, we have F here, so let it be as we have it already. We already have B, it will come. Now let's talk about B. D is coming. We have D. C is not here. So C is coming in which class? A is coming in C's class. So here it will be A and here 0. Now let's talk about D. Here E is coming and we don't have E here. So E is equivalent to which one? It is equivalent to B. We will write B. And here we will get this. And here we will get 1, right? Same we will take F. We already have it. Here A and G is coming in F. So A will be as it is because we have it. Now let's see G. G is for which one? F, right? We will take like this one. So students, what we will get here? The table will be minimized and this will be its equivalent. Okay. You must be thinking that instead of F, we can write G. Yes, you can write H, or you can write E instead of D. Basically, it depends on you. Now let's move ahead. Next question says, show that the 2 finite state machines shown in the following table are equivalent. You people are being asked that if these 2 are finite state machines and if these are equivalent. So we will minimize this. Again, we will minimize it. Now, the output of both should be same or they should be equivalent. If this happens like this, that 2 state machines or minimized state machines are equivalent, then this will also be equivalent, right? So let's do it one by one. First of all, let's minimize this. So all I will talk about is of table first. Yes, table first, okay? Then we will discuss about table 2. We will take table 2 here so that you can understand. This is table 1 and this is table 2. Now let's talk about table 1. Listen, what are the states that are giving 0 output here? These here, we will get A, B, C, D, E. We will calculate by 0. So students, here we will get A, B, C, D and E in 1. Okay? And students, what is the second one? It will be FG, right? We will get this. Now we will break it. We will name it as 1 and other as 2. We will talk about by 1, that is 1 equivalent state, right? Now in 1 equivalent state, let's take A first. So we have A here, right? What is coming in A? Here B and C are coming, right? So B and C, therefore this will be 1, 1. Then we'll take B. In B, BD is coming. This is also becoming 1, 1. Next, let's talk about C. We have A and E coming in C. So A and E is also 1, 1, right? After this, let's talk about D now. We have BE coming in D. So this will also be 1, 1. Next, we will talk about E. We have F and E coming in E here. So F and E will be what? 2, 1, right? So these 4 will come together and this E will be separated. So students, what will come here? A, B, C, D and this E will be separate and here will be F, G. No need to do this because it can't be less than this, right? We will move ahead. Now let's talk about 2 equivalents. So for 2 equivalents, same again, A, B, C and D. Okay. Is this clear to all of you or not? Because E is separate, so there is no need to check it. Now we will take A. Now if we take A, then we have B and C. So B and C are coming here. So we have 1, 2 and 3. So listen, we'll take 1, 1, right? Let's talk about B. In B, BD is coming. Here is BD, so this is 1, 1. And after this, we will talk about C. In C, AE is coming. AE means that it will be 1, 2. Keep this in mind. Now, if we talk about D, here in D, BE will come. So this will also be 1, 2. So we can separate both of these. Okay. This will be separate and this will be separate. Now we have 2, 2, so no need to check it further. So students, here we will have A, B, okay. Now here we will have C, D and then E. Next we will have F, G, right? Is this clear or not? We will get this. Now what do we do in this? Let's deal with each one of them one by one so that you don't have a problem understanding things. So what we will do? We will find finite state machine equivalent to this. I will change color. Now take this. Students, here we will delete this one because we have to understand it clearly. Okay. Let's see which states need to be removed. We will remove those states. Here in this, AB is there, so I will remove A from both of these and I will keep B. And then CD is here, so I will remove D. We need E, we need this, we need this, we need E. I will remove G from FG, right? So we will make its output table here. Here this is the state and here this is the input, right? Right? The same 0, 1, right? 0, 1 will come. And this will be what? The output. Okay? So this will be the table. Now let's deal with this. Students, here will be A, C, here E and F, right? Is this clear or not? Now students, here we have A. What we will have here? B and C, and we already have B. No, sorry. We don't have B here. Yes, we don't have B. So we have to take the equivalent of B because B is not here. So equivalent of B will be what? It will be A. If we don't have B, then equivalent of B will be A. We will write A here and we have C, let it be. We'll get 0. Now let's talk about C. A and E are coming in C, right? Now A and E, A is here, so take it. E is also in this. We will take this. 0 will come here. We have F and E and E. So there is no tension. F and E both are coming in this. It will be the same. And the output will be 0. Now if we take F, we get AD. Here we are getting A, but we don't get D. So for D we have C as its equivalent. So we'll take it. And here we will get 1. So this will be our minimized table. Retain. Now let's talk about table 2. So we will deal with this one properly. Okay. Yes, we will talk about this one. Okay. So when we will do table 2, let's change the color so that it is visible. First of all, we will take out its 0 state machine. So what do we have here in 0 state? This and this. So this is our equivalent state. This is 0 equivalent. So what will this be? A, B, C, D, E and H will come here. Is this clear? One will be this and the other one will be FG. We will get this one. Clear? Remember this. We will name this as 1 and this as 2. Then we will calculate pi 1. If we calculate pi 1, first of all, write A, B, C, D here. So here we will write A, B, C, D, E and H. Okay. Since these two are alone, so no need to worry about these. Now let's talk about A. Here in A, H and C are coming. You can see both are same. If we talk about B, it's GB. Here is GB, it will be 2, 1. Right? I think it will be 2, 1. Next, we will talk about C. C is coming to be AC here, so it will be 1, 1. Now if we talk about D, it's DC. So clearly this will be 1, 1. If we talk about E, it's HB. Here is H and here is B. This will also be 1, 1. Right? Now let's talk about H. This is AE, hence this is also 1, 1. So there is no need to take tension. Here what will happen? Listen, here this AC and all these will come together. B will be alone, right? Here we will get A, C, D, E, H all together. Okay? Is this clear to all of you or not? And here it will be B and here it will be FG, right? We need to pay attention to this. Again, take this as 1, this as 2, 3. Okay? Is this clear to all of you? Now let's move ahead. Before we move ahead, let me clear this first. So students, next we will talk about this one. Here we will have what? We will have A, C, D, E and H. Okay? We will calculate it. First, let's talk about A. A is giving. Here H and C, H is coming here and C is coming. It will be 1, 1. Now let's talk about C. In C, A, B is coming. A is coming here and C is coming here. So this will be 1, 2. Let's talk about D. It's DC. DC comes in same category, so 1, 1. Now let's talk about E. It's HB. If HB, then it will be 1, 2. Now let's talk about H. A and E will come in H. Here is A and E is here, so this will be 1, 1. Now students, here we will get ADH together. Like this we will get pi 2. So here we will get ADH after this C, E will come separately. Right? Is this clear or not? Like this we got these. We already have B. Now here we will have FG. Right? Again 1, 2, 3, 4. Now we have to break this further. For the rest we don't have to worry much because it's done. So what we will do for this one? Now next we will check the 3 equivalent. So when we will check for 3 equivalent, if we check, then what we will do? So we will calculate the pi 3. Now we will talk about ADH. Yes, you heard it correct about ADH. First let's take A, H and C is coming in A, H is here and C is coming here. Therefore this will be 1, 2. Now let's talk about D. So in D, DC is coming. D and C will be here. Therefore it is 1, 2. Now let's talk about the H. So what do we have in the H? We have A and E. CA is here, E is here. This is also 1, 2. It is giving same output. If it is giving the same output, then leave it. This is not necessary. We will get this only. Getting my point or not? Now what we will do when we are getting this? We will calculate its table and after that we will check which are getting minimized. Now let's minimize. For example, ADH is here. So from ADH, we will keep 1 and minimize any 2. So let's remove D and H. We removed D and H. Okay. Now students, we will write A here like this. Let's move ahead. Here is C and E. I'll remove E from C and E. So removed it. I have to take B. We have to take this one as well. Here we will remove anyone from F and G. I will take this. After this, let's make its equivalent table. So first we will get the state here and then we will get the input. Yes, same 0 and 1. And this will be our output, right? We will make this. Is it clear? Now tell me what will be here. Here will be A, B, C and F. Is this clear to all of you or not? Now let's talk about this. Here we have H and C. We don't have H, but we can take A instead of H. So this will be A, right? And C will be here and here will be 0. Now let's talk about B. GB is coming here. We are getting GB, but we don't have G. G is equivalent to what? It is equivalent to F, so F will be here. Here we will get B. This will be what? It will be 0. Let's talk about C. AB is coming in it. We already have A, so we'll get A here as well. And this will be 0. If we talk about F, then we have D, but we don't have D. D is equivalent to A. And E, so E is equivalent to C. Is this clear? Output of this is this one. Okay, you can see here output is 0, 0, 1. Here also output is 0, 0, 1, right? Here we are getting A, C, E, F, and here we have A, B, C, F. Basically, the output should be same. If output is same, then both state machines are equivalent. So this is minimize of this, and this is minimize of this, and the output of both is same. This time, these two state machines are equivalent. This is how we do it. So we will solve second one like this. So students, this question is for you in comment box. You have to find which state in these is 0 equivalent corresponding to this table. Okay. How much time did it take you to solve it? Please do tell me. Listen, here you will get my complete playlist on discrete mathematics. If you are preparing for CSIR NET, GATE or IIT-JAM exam, I have uploaded many videos on it. You can watch them here. You can subscribe to channel and you can follow me on Instagram. Thank you so much for watching me. Like, share and subscribe to the channel. Press the notification bell so that you get the notifications of the upcoming videos. Do answer this in the comment box. Thank you.